Okay, somebody asked me to do a quick video on the categories of numbers, so let's do that. There's like a million videos on YouTube explaining the categories of numbers and how they work. But I'm gonna try to do mine in my own style, okay? So let's go. So I want you to imagine a magical place, like a
place where everything exists and it's possible.
Except for numbers. Let's say that numbers do not exist in this place. And by the way, this is a real story, not. So in this place, right? There was a group of people, and they had a bushel of apples, right? And they wanted to split the apples between themselves. And the leader of the group started giving away the apples, one for you, one for you, one for you, one for you. And all of a sudden, he stops and he looks at one of them and says, "Hey, how many apples do you have?" And the guy goes like, "Huh? What do you mean? How many apples do I have? I don't know. In this place, numbers don't exist, so I don't know." And one of them goes like, "Well, count them." And he goes like, "Count them? What is that?" And he goes like, "Well, take one apple and put it here. You have one apple. And take another apple and put it next to it, and now you have one and one. You have two apples." And that's how numbers were created. The easiest way to think about natural numbers, let's say natural numbers, it's to think about the numbers that you use to count things starting with one, because that's so natural. We all count. We all have to count. Every single day of our lives, we have to count something, and we start counting on one. Okay, so there's 1, 2, 3, 4, 5, all the way to infinite. So those are called natural numbers because they are used to count things, right? What happened was that when they finished, dividing the apples between themselves, one member of the group who was late to the meeting got there and said, "Hey, I just got here. What's going on? And hey, we're splitting apples. And by the way, we created something called natural numbers because we needed to count." And he goes like, "Well, I don't have any apples. Where's my apples?" And they all looked at each other and said, "Oh, wait, he doesn't have any apples. We don't have, in this group of natural numbers, we don't have something to represent the absence of apples. So no apples. What do we do? Oh, we'll create a number called 0. 0 will represent the absence of things." And one of them says, Hold up.
Wait a minute. Something ain't right.
Because if natural numbers, he says, if natural numbers are used to count stuff and 0 is the absence of stuff, then 0 cannot be counted, right? So we cannot include 0 in the natural numbers because natural numbers are used to count. And so they all go like, what do we do? And one of them says, "Okay, so let's do something. Let's take the 0 and include it with all the natural numbers, right? But let's give that group a different name. We'll call those whole numbers. Whole numbers. Now, whole numbers are the same as natural numbers, 1, 2, 3, 4, 5, all the way to infinite, but this group is going to include 0. So let's look at this very carefully, because if you have a natural number, meaning 1, 2, 3, 4, 5, any of these numbers all the way to infinite, you also have a whole number. Let's say that you have a 2. Well, 2 is a natural number, but it's also a whole number. So every natural number is also a whole number. But hold up, not every whole number is a natural number, because if you have a 0, you have a whole number, but you don't have a natural number because 0 is not in the natural set. Okay, you see how it's putting it together? How we're putting it together? So the guy that had 0 apples, the guy that had a whole number of apples, got mad, and he turned around and he kicked one of the apples of another member on the group, and that apple just split in pieces. And the guy said, "Hey, what you doing kicking my apples? You wasted one of my apples. You owe me an apple," he says. And the guy says, "Well, I don't have any apples, bro. I cannot give you the apple back because I have zero. I have a whole number of apples, which is zero. And the guy goes like, well, okay, next time you have an apple, the next time you get your hands on one apple, you don't even have that apple because you have to give it to me. And then the leader of the group said, hold, wait. Because now we're talking about owing. Now we're talking about having an amount less than zero. You mean that he has zero, but even if he gets one, he still has nothing because he has to give that one to you, back to you. So he has one less than zero. How do we do that? I mean, we have the natural numbers, which are 1, 2, 3, 4, 5. We have the whole numbers, which include zeros, but we don't have a set of numbers to include numbers less than zero. What do we do? And so they came up with something called integers. Integers. And before they came up with something called integers, somebody had the idea to call some numbers negative numbers. So they said, okay, we're gonna put zero in the middle, right? And after zero, we're gonna have all the natural numbers, 1, 2, 3, 4, 5, all the way to infinite. But if you owe one apple, you're gonna have -1. And if you owe 2 apples, you're gonna have -2 and -3 and all the way to negative infinite. So the integers include all the natural numbers, include zero, but now include numbers called negative numbers used to depict amounts less than zero. All right? And that all happened because this one guy kicked one apple and now he owed one apple. True story. Look it up. Google it. So now take a look at this. We use the 2 as an example, right? So if I gave you a 2, you have a natural number, you have a whole number, and you also have an integer because 2, it's in the integers group, it's in the whole numbers group, and it's in the natural groups. But if you have a -1, you have an integer, but -1 is not a whole number and it's not a natural number. So you got to be very careful when you see a number and think about what numbers are in which group, and you will be able to decide where that number goes. Now, here's the thing. The guy that had no apples, right, and that now owed one apple was so sad that one of the members of the group said, you know, bro, I really feel you. And I hate that you don't have anything. So I'm going to give you one apple so that you pay that apple that you owe, right? And you leave the integers group and now you go to the whole numbers group because you'll have zero, but I'm going to give you half an apple so that you have something to it. So I'm going to take one of my apples and I'm going to cut it in half and I'm going to give you half an apple. And everybody went back and said, whoa, stop. What do you mean one apple? We don't understand. What is half of an apple? We know one apple. We know 0 apples. We know -1 apple because you have less than 0. But half an apple? What are you talking about? And the guy goes like, well, I'm going to take an apple. I'm going to cut it in half and I'm going to give it to him. So how do we talk about that in numbers? How do we talk about that mathematically about half a thing? What if next time you decide to cut the apple in 5 parts and you give him one of those 5 parts? I mean, you would be given 1/5 of the. Oh, wait. Are we talking about fractions? Said one of them. Hold up. In between all these numbers, in between 1 and 2 and 2 and 3 and 3 and 4, and in between -2, -1, and there's more numbers. We learned that in elementary school, right? They're called fractions. And by the way, they're called also decimals because every fraction is also a decimal. So hold on. If we are going to include now decimals and fractions, which is the same, we need a whole other group, a whole other category of numbers, right? To talk about these numbers because integers don't include fractions and decimals. Whole numbers don't include fractions and decimals, and natural numbers don't include fractions and decimals. So what do we do? All right, so let's come up with another group called the rational numbers. And the rational numbers are going to include all the natural numbers. So all of these numbers are included here in the rational numbers. It's going to include all the whole numbers, meaning 0, because all the whole numbers are all the natural numbers plus 0. And it's going to include all the integers, but it's also going to include fractions and decimals, which is the same. I should say fractions or decimals because it's the same. So here we have basically 4 categories of numbers that have most of the numbers known. There's still another category called irrational numbers, but we'll talk about that in another time. So when you talk about rational numbers, you have natural numbers, whole numbers, integers, and fractions and decimals. When you talk about integers, you have negative numbers, positive numbers, and 0. When you talk about whole numbers, you have 0 and all positive numbers, or all natural numbers, numbers used to count. And the natural numbers are numbers used to count. Now, this is how these 4 categories came up. And you can find that story in the history books of my own library. So what we're going to do on the next video is that we're going to go over 4 or 3 problems that you may encounter on a test where you have to kind of use this information to know where do they belong. All right, so see you on the next video. Boom.